and welcome everyone to our Fronius webinar. Today we shall be discussing Fronius products and solutions. So basically we shall be discussing the products that Fronius has out there in the market, and then also discuss the solutions that we use these products to prefer. Of course, I'm not alone to do it today. I have my colleague, Byron Kutzer from South Africa. He is a technical sales advisor for the Southern Africa region. He's based in Joburg, South Africa. Then, of course, myself, Cyprian Okolo, I'm the technical sales advisor for the Western Africa region, based in Lagos, Nigeria. Let's now take a look at the agenda for today's webinar. So first off, we'll be giving you a brief inverter history, Fronius, of course, and then we'll go through the Snap Inverter series, take a look at the attributes of these inverters, delve into the smart meter, home pilot, Gen 24 Plus series. That's the Fronius hybrid inverter. And then afterwards, Byron will come in and then take over from there to continue with the Watt Pilot, AC coupling, the Fronius Tauro, PV gen set systems or solutions, and then give you a brief information afterwards. Good. So without further ado, let's get into the webinar. So how best to start? Giving us the inverter history, than going through a Fronius product chronology. So as you can see, we've actually started a long while from 1995, the inception of our very first inverter, the Fronius Sunrise, up till 2021, where we rolled out our commercial inverter, that is the Fronius Tauro. So we shall be dwelling mostly on the Snap inverters, the Gen 24 Plus series, that's the hybrid inverter, and then of course the Fronius Tauro, and then other products that we have out there in the market. Good. Let's now start off with the Snap inverters. So it pleases me to tell you that we've actually done this over 1 million times. About a year ago, we actually hit the 1.5 million inverter manufactured, Snap inverter manufactured. And the picture here you can see was to mark the commemoration of the 1 millionth Snap inverter manufactured. So that was commemorated by having a gold-plated Snap inverter. This was randomly packed and shipped to various continents around the world just to mark this occasion. And for us to do this over 1 million times means that we're doing something right with our Snap inverters. And of course, it's making a huge mark in the market. So let's just give us a brief of details of our Snap inverters. So we have them for residential and commercial solutions. So for the residential solutions, we have the Galvo, the SYMO, what we usually call the small SYMOs, and then the Primos. So these are the inverters normally implemented for residential solutions. So for the Galvo, it basically ranges from 1.5 kilowatts to 3.1 kilowatts. And then the SYMO, or the small SYMO, ranges from 3 to 8.2 kilowatts. The S and M here means that it has a mixture of inverters that have single MPPTs and then those that have multiple MPPTs. So that's what S and M stands for. And then the Primo ranges from 3 to 8.2 kilowatts, as you can see the details here. All SYMOs are actually 3-phase inverters, while the Primos are single-phase inverters. And of course, you can also see there are various other features that the inverters have. A point to note here is that the Galvo has been discontinued, but then all customers that have Galvos installed still enjoy the same support as the other inverters. And I can also tell us here that those that still have the Fronius Sunrise, the very first inverter that was manufactured since 1995, also still enjoy the same equal amount of support from our tech support staff. Yeah, so that means that inverters, the same sunrise actually in existence up till today, which tells a very good story about the ruggedity and the durability of our inverters. Good. Let's continue to our commercial snap inverters. These are what we call the big SYMOs and then the Echo. For the SYMOs, it ranges between power classes 10 kilowatts to 20 kilowatts. They have multiple MPPTs. You can have as much as 6 strings, 3 per MPPT. And then we have the Echo. The only difference between the Echo and the SYMO is that it has a single MPPT, but can also take up to 6 strings. So it has just 2 power classes, that is the 25 and 27 kilowatts. Good. Let's take a brief look at our snap inverter attributes. First up is its easy installation and service. This is so because our inverters are modularized. It has a light wall mount bracket that also has integrated on it all the electrical connection terminals and points, both for the AC and DC. So this makes it easy after mounting the wall mount bracket to now snap in the inverter. So because of this, it makes installation quite easy and pretty fast. So in most cases, of course, once you have done all your installation preparations, it usually takes less than 7 minutes to install. In terms of temperature coefficient, our inverters actually stand out because it can be installed for every location. Active cooling concept makes it have the highest protection class and of course prevents hotspots. This of course guarantees a long lifespan. Yeah, so for mounting locations and the temperature coefficient as it is related, it can be mounted for in regions with temperatures of from minus 25 degrees to 60 degrees centigrade with IP or ingress protection, as you would say, class of 65 and 66 respectively. That's depending on the inverter in question. And as you can see, our inverters go through a lot of tests rigorously to ensure that they withstand whatever conditions where they are installed. Next up is the SUPERFLEX design, which comes with a broad input voltage range. For the Primos 80, for the SYMOs 150, and of course maximum DC input voltage is 1000. So which means that this makes it possible for you to have installations at on areas on rooftops where you have varying orientation. So whatever be the case, you can have your inverters flexibly installed, be it where you have, if it's a rooftop that has a small area, for instance, that has a small space for installing the solar panels, and then you have other parts of the same roof that has more area to install, it's really not an issue because you can actually have our inverters accommodate unsymmetric solar panel distribution. So you can have it as wide as 80 to 20% disparity. Another good thing about our inverters is that they can be over-dimensioned up to 150%, meaning that you can install, say, if you're dealing with a 20 kilowatt inverter, for example, you can actually install solar panels up to 30 kilowatts capacity on it. Yeah, and having said that, of course, it can support symmetric solar panel distribution, of course, following the respective relative orientation. So in this case, for an oversized, 150% oversized, you can easily have them distributed 75% on each orientation. Good. More yield in shading conditions. This is usually a problem for solar panels because shading conditions can easily occur, maybe due to maybe a tall building per se, or maybe a street light, and then of course a chimney, as you can see in this case. So this tends to cast shadows on the solar panel. So once this is done, it immediately drops the amount of power they're able to produce. But then with the MPP track algorithm that is integrated in all our inverters, it makes it possible to locate the best operating power point even in shading conditions. And then this, of course, leads to high yield because of this increased flexibility per se. And to shed more light on the dynamic peak manager, this is a graph that shows how this works. So instead, under shading conditions, as you can see in this case, instead of having a power at this power mark, so according to the local MPP inverter, according to the algorithm, or the algorithm that is integrated, searches for the optimal working point and of course adapts dynamically. So this scan is usually continuous, and then as it scans and then finds out the best working point or the best maximum power point, it automatically shifts to that power point to ensure that you have more yield than what you would have gotten without this integrated dynamic peak manager. Good. Now let's talk about the smart meter. The smart meter TS is actually a new smart meter that was rolled in about a year ago. This actually replaces the old smart meter. So it's called TS. The TS here stands for touch screen. So the previous version wasn't actually touch screen. So we have rolled out a new smart meter, which of course retains the same function that is giving us the best means to carry out analysis and visualization of both production and consumption data. And it is actually key for monitoring an efficient energy flow control and of course for energy management. It is of course a bidirectional meter, meaning that it measures both production and consumption. And of course, it means that it differentiates between consumption from the grid and of feed-in energy. That is when it is feeding in to the grid. Good. So for the smart meter, we have three variants. We have the single phase variant for residential system. We call it, it comes, the amperage is 100 amps. So we call it the 100 A1. So this has an ampacity of 100 amps. The next is for the same residential but three phase. So this has an ampacity of 65 amps per phase. And then we now have the industrial smart meter for industrial purpose. So this has an ampacity of 5 kiloamps per phase. But of course, we know that this is actually a high figure in terms of the current. So we would need what we call current transducers to step down this high current to a much more friendly current, usually 1 or 5 amps. Good. Let's now talk about the Home Pilot. The Home Pilot comes in very handy when we want to generate hot water for later use. So this was actually what Fronius had in mind while producing this particular product here. So it, of course, increases self-consumption by, of course, steplessly controlling heat sources. So these heat sources should be purely ohmic loads. So where it finds its application is in heating rods in boilers and storages, or of course water storages, infrared heating panels, towel dryers, and of course other ohmic loads. To give us a clear picture of what we mean by this is we have a description of what we mean by ohmic load. So we have one here which is an electric floor mat per se used for heating. We have infrared panels, and then of course heating rods that is installed in a boiler. So how is this applied? Let's say we have a scenario where we're generating 1.5 kilowatts or 1,500 watts. And then our power consumption just takes 1,000 watts. It means we have an extra of 500 watts. So for regions where it's allowed to feed into the grid, you can now have this 500 watts being fed into the grid. But then wouldn't it make sense to actually, make use of this power for something else you might need later on? Because whatever you feed into the grid, by the time you want to buy it back, you're going to be buying it back at a higher rate than you fed into the grid. So this it's the main reason where it calls for an increased self-consumption or self-sufficiency. So what happens in this case when the Fronius home pilot is connected in this system is that this 500 watts is now channeled to trigger, in this example, a rod. So this boiler, of course, generates hot water that will now be eventually used later on. So that's the advantage that the home pilot comes with. Good. Let's now go into one of our flagship inverters out there in the market, the Gen 24 Plus series. The Gen 24 Plus is actually a hybrid inverter. It's uniquely versatile and has what we call an all-in-one solution in terms of energy sector integration. So we're just going to go briefly into its features, starting up with the Fronius Primo. The Fronius Primo, yes, is a hybrid inverter, single phase. It has 2 MPPTs and then 1 battery output. So for it to be called a hybrid inverter means, of course, that it is battery connectable and has power class ranging from 3 to 6 kilowatts. And then the SYMO, which is a 3-phase inverter, of course, is a hybrid, has the same MPPT as the Primo, that's 2, and then, of course, 1 battery input. And then power classes ranges from 3 to 10 kilowatts. I'm going to still shed more light on this power class with the next slide. So for the SYMO, power class 3 to 5 kilowatts comes with some certain features that are not basically unique to it per se. So that's the 3-phase 3 to 5 kilowatts. So we're going to see these differences in features in the next slide. So let's have a bit of a comparison. So starting up with the SYMO hybrid. The SYMO hybrid, as you would know, is the old version of the SYMO hybrid inverter that has been discontinued already. So these are the features. But then for the comparison I was talking about that we're going to make now is for the power class 6 to 10 kilowatts, that is for the 3-phase. So these are the features. So power classes ranges from 6 to 10. So to be specific, we have the 6 kilowatts, 8 kilowatt, and then the 10 kilowatt power classes. The MPP tracker is 2, as mentioned earlier. So the first MPPT, as MPPT1, has an ampacity of 25 amps, and then MPPT2 has a current carrying capacity of 12.5. MPP voltage range is from 80 to 800, and then the battery input has a current ampacity of 22 amps. Compatible batteries for now is the BYD Premium HVS and HVM batteries. Backup options include the full backup and, of course, the PV point. I'll be shedding more light on these 2 features after I have compared it with the other power classes of the Gen 24 Plus SYMO. So for power classes 3 to 5 kilowatts, to be specific, 3, 4, and 5 kilowatts, the MPP tracker current ampacity is equal in this case, that is 12.5 each. And then the MPPT voltage range is the same as the 6 to 10 kilowatts power classes, but then the battery input ampacity is 12.5 amps as against 22 amps for the power class 6 to 10, and then 25 amps here in terms of MPPT1 when compared with that of power class 3 to 5 kilowatts, as you can see. Good. And then another difference is that it doesn't offer full backup option as is offered by the power class 6 to 10 kilowatts. Good. So for battery storage solution, Like I said, or like you've seen in the previous slide, it's solely compatible with, for now, with the BYD battery box Premium, HVS and HVM. So it's actually a lithium-based battery cell that has modules of 2.6 and 2.8. 2.6 kilowatt hour for the HVS, and then 2.8 kilowatt hour for the HVM variant. So for the HVS, you can actually, the minimum stackable module that you can have is 2 modules. So you'd have 2 modules of 2.6 to give us the minimum module, stackable module from 5.1. So this can be stacked up to 4 modules. That is taking us up to 10.2 kilowatts. That is for the HVS. And then for the HVM, the minimum stackable module is 4. That is the 2.8 kilowatts hour modules. So if you have 4 modules of that, that's the minimum stack that you can have, and then you can go up to 22 kilowatts, 22.1 kilowatt hour. That is making constitution of 8 modules of the 2.8 kilowatt hour power module. Good. And an extra feature is that it's easily installed and ground mount, and then the commissioning is actually straightforward and easy. Good. Our Gen 24 Plus series inverter comes with a unique feature called the multi-flow technology, meaning that it flows in all directions, meaning that, of course, you can convert DC from DC to AC, that is supplying your load line directly from the PV generator. You can also have it feed into the grid, that is from same DC to AC. And then, of course, you can have a DC to DC flow, meaning you can, of course, charge a battery directly from the same PV generator, which, of course, which is surplus power. And you can also have, in the case of backup, you can have power drawn from the battery to your load, meaning a DC to AC conversion. And then, of course, have an AC to DC conversion. That is when you're now taking power from the grid and then charging your battery with it. And this is easily retrofittable because you can have your snap inverter installed and then all tied on the same AC bus bar. Good. So please, as the webinar is going on, please feel free to send in your questions and we'll be more than happy to attend to them. Good. So like I was saying that I was going to give shed more light on full backup power. Yes, it actually offers full 3-phase backup power, of course, enabling an overall supply for the entire household. Usually the maximum, the automatic switchover takes less than 60 seconds, way less than 60 seconds. And I can tell you here that we're actually putting more effort into this to reduce it to the barest minimum. And then for electric loads, of course, you can take both. We have, of course, with respect to the inverter you're making use of, if it's a 3-phase or a single phase, it can supply them. And then another unique feature is that it can supply maximum energy consumption through its parallel charging and discharging flow. Good. Another unique feature of the Gen 24 Plus inverter is the PV point, which we normally call opportunity power. So this means that you can actually have power even without battery backup. Yeah, so long as there's irradiation, you can actually have battery backup even without grid or battery. So that's it. And in case of power outage, that is when it automatically connects to this PV point. And this PV point can supply up to 3 kilowatts single phase, and then a maximum transient supply of 4.1 kilowatts in order to support devices or equipment that have a relatively high starting current. Yes, it's easily installed. No additional accessory needs to be installed to make this possible. Yeah, so what we, just to have a good depiction of what the PV point is all about. So even without the grid, you can actually have power delivered to your PV point, even without battery and the grid, as you can see. So when, of course, the battery is optional. So if you have the battery available, you can have power to charge the battery, and then, of course, have battery supply to this load point. Yeah. Great. So with that, I have come to the end of my part of the presentation. I will now be handing over to Byron, who will be taking over from this point to continue with the Fronius Watt pilot. So Byron, if you're on, please, you can take over from this point.
Thank you, Cyprian. So we're going to be talking about the Fronius Watt pilot, which is our EV charging solution. Our EV charging solution is available in two different variations, which is the Go and the Home setup. Our Go version is available in 11 and 12 and 22, sorry, which is 11 kilowatts and 22 kilowatt variant. Same AC connection. It's a CEE 16-pin plug, 5-pin, including the neutral pin. And the Go version of the 22 watt has a 32 plug red 5-pin, including the neutral pin. And then our Watt Pilot Home version is only available in 11 kilowatts, has a 3P NPE 400 volt or 230 volt 2-meter connection cable, and it has a nominal current, so from 6 to 16 amp, 6 to 32 amp for the Go version, and then from 6 to 16 amp on the Home version only, single phase or 3-phase for all versions available. This is a functional overview of how you would wire your Fronius Watt Pilot. So you'll have your PV generator, your Fronius inverter, also communicating via a Fronius smart meter, and you'll have your Watt Pilot Go or Home version connected in your system itself, and it will be monitored via network to communicate via the Fronius Watt Pilot and with your Fronius inverter. It'll be the same if you're using a hybrid or a normal grid tie inverter in that sense. It's exactly the same, even if it's 3-phase, so it'll be over one single phase or 3-phase you're charging. For our Fronius SOLAR.WATTPILOT app, so this will be ensuring easy commissioning of the unit itself, the monitoring and changing of the charging modes, and this is available for Android and Apple devices. So as you can see, you have full charging capabilities, so you can set the mode, your currents, the time that you need the vehicle available, for example. It'll show you the range, as well as what happens is you can have your vehicle itself loaded onto the device. So some versions of the vehicles are available, such as VW, Tesla, BMW, where it will smart allocate what the battery's capacity is and how many kilowatt hours you need for a certain kilometer distance. For our AC coupling solutions, so this is where you are pairing a Fronius inverter, single phase or 3-phase, with a Victron or Tesla Powerwall, for example. So you will have your residential, so normally a single phase inverter or smaller 3-phase inverters. And then on your commercial side, you'll have your larger 3-phase inverters for your off-grid applications of AC coupled. For the DC coupling, so this is when you are connecting directly of the PV generator to the battery. So this is where you'll have your PV generator with your inputs from your strings itself connected to the battery to help charge with the Victron itself, with your Victron distributing the loads to your household. For AC coupling, this is where you'll have your PV generation, your Fronius inverter, your Victron inverter, and your battery itself. And in this instance, you will have your PV generator will be assisted by the Fronius. We will then communicate or feed for load directly to your household or feed the AC back to the Victron inverter, which will then help charge your battery that is coupled with your Victron. For an AC and DC coupling, for example, the combination of both advantages. So this is where you'll have, again, your PV generator connected to your Victron charge controller, your Fronius inverter, and they will both assist in the charging of the battery in this case. The same with your Victron helping distribute loads to your household or the Fronius directly to the household. Again, you can also couple it with a generator to help assist if your battery load is not capable of supplying your demand. Then the optimal interaction, so this will be your Fronius inverters and inverter chargers. So as said, this is where you will utilize your Fronius as supplying directly to the household and supplying also to your Victron to help charge the battery itself, or where your Fronius will be taking majority of the load to help stabilize the load itself under cloudy days. So it'll be taking from the battery through the Victron and then back up into your household loads. What happens if the battery is fully charged? So in this case, what will occur is your PV generator will go through the Fronius to help charge the battery. Then as soon as the battery is fully charged, your Fronius will then be only supplying directly to your household load. And the inverter with the Victron and the battery will be idling as soon as it's needed. So the frequency controls power reduction interaction of the components. So this is when automatic power reduction in case of a fully charged battery or power factor. If the battery is fully charged, the Victron component increases the AC frequency, and then with an increased AC frequency, the PV inverter reduces the feed-in process. So they both work hand in hand in that sense. This is just a demonstration of showing how exactly. Then onto our Fronius Tauro inverters. So it's a hard shell, it's a smart core. So the Tauro is available in two different variants. So our Fronius Tauro Eco and then our Fronius Tauro itself. So for the Eco, it's available in two different power classes. We'll have a 50 and 100 kilowatt size. It's only got one single MPPT. The MPPT voltage range for the Eco is from 580 to 930 volts and maximum DC voltage of 1000 volts. The weight is from 72 to 110 kilograms, and then this is again depending on the variant that you have. So for the 50 kilowatt variant, it'll weigh probably 72 kilograms, and then for the 100 kilowatt, it'll weigh 101 kilograms. For our Fronius Tauro, this is our normal version. So the Fronius Tauro is only available in the 50 kilowatt power range, has 3 MPPT trackers, and the MPPT voltage range is from 400 to 870 volts, with a maximum DC voltage again of 1000 volts. And its weight is also 74 kilograms. What is the motivation behind it? So since commercial PV systems usually means a large investment, the systems must therefore be lucrative and the investment must generate a high return. This is why the so-called TCO, which is total cost of ownership, should be as low as possible. And also important that the PV system achieves a high yield so that it can pay for itself quickly in addition. And the saving of the BOS. So this is a PV system always starts with a system design where the planner makes a range of fundamental technical and product decisions, and keeping the BOS cost as low as possible requires a certain design flexibility on the part of the inverter. And the Tauro offers a number of advantages. Then the Tauro versions. So here we have the power stack, the 2 DC switches, and this is for the normal Tauro Eco 53 kilowatt, 3-phase, sorry. Then you'll have the power stack, the 2 power stacks, and then the 2 to 3 DC switches, depending also on the variant. So on the Tauro Eco 100, it'll have 2 to 3 DC switches. Then you'll have the P version, which is the pre-combined, and then you'll have your D version, which is a direct version, which houses MC4 connectors. Pre-combined or direct, what is the difference? So P to be used in central inverter positioning, or the D version to be used in decentral inverter positioning. So this will help with costing for AC cable, whether it's been on the DC side or on the AC side. It gives you full options of availability and customization. So the P&D Tauro variants. So again, you'll have your central design system design and your decentralized system design. The individual system design is made possible by various product designs, and pre-combined variant is ideal for a central system design. But if a decentralized system design is preferred, the direct variant is the right choice. Again, the direct variant has integrated fuses and string monitoring. For our Tauro AC daisy chaining, so this is where you'll have multiple Tauros connected on the AC side coupled together. So it allows you up to 200 kilowatts, so 2 by the 100 kilowatt Tauro Eco, or 4 by the 50 kilowatt Tauro Eco. This will ensure cable savings, fewer AC cables required, fewer components, no AC combiner, so you'll just have one AC disconnector per 200 kilowatts. This will also ensure more yield due to less cable losses. For your total cost, you'll have your yield, which will give you then your levelized cost of energy. So you will want to ensure a lower TCO, but as you have seen, the Tauro also generates a high yield at low TCO, and high yield lead to low levelized cost of energy. For our Fronius PV genset solutions, we have 3 different classes, so it's easy, advanced, and professional. So normally you'll have a Fronius PV genset easy off-grid. So this is where you'll have your PV generator, your Fronius inverter, your PV genset controller itself, and you'll have your generator connected. For the off-grid version, so this is where you'll have no AC reference from a municipal or grid operator side, where you'll be utilizing fully from the generator and your PV side to help generate your load capacity. For the grid backup, so this is when there was in the case of a grid failure, so then you would utilize your generator and your PV in order to stabilize the loads that are demanded in case of a grid failure. So it's commercial and industrial. So commercial and industrial C&I applications benefit most from the PV genset solution. And then on a single genset, the Fronius system PV controller is optimized for single genset application up to a maximum genset power of 1.2 megawatt. Lower voltage, so the Fronius PV system controller is suitable for LV applications or start topology. It's a retrofit design, so the PV genset solutions are commonly used for retrofitting. Our solution PV genset Easy fits best for systems between 50 and 500 kilowatt peak. Our off-grid backup, so not just for off-grid, but also weak grid or backup applications can be optimized with the PV system controller. For our Fronius PV genset Advanced / Professional, so Advanced means Easy Plus, so you have multiple genset retrofit, so it'll be independent from the voltage level, so either LV or MV, and also your genset controllers itself. So the benefit is more complexity. Professional means advanced, so this will be for multiple genset controllers, and the benefit is ultimate solution for power management for PV on eye level with genset power plant. For any further information on our products and solutions, it is available on our homepage or the operating and instruction manuals at www.fronius.com/en/downloads, or on our YouTube channel on how to install videos, webinar recordings, and our sub-Saharan African panelists, where you can view products and solutions that are tailor-made for the Sub-Saharan Africa. For your Fronius Solar Energy team, for technical questions, trainings, sales international, and after-sales service, please do contact. And for TSA Southern Africa, please contact myself, Byron Kutzer. For Western Africa, Cyprian Okolo. And then for Eastern Africa, please contact David Mangwi. And thank you very much.